So here's chapter 4.3. This is the second diagram. This is the second way that you can actually set this one up. So this time, the distance in between me and Mr. Laidlaw is down here. Same distance in between us, only this time we're both looking up at the kite mess from the same direction. We're both looking up to the left. We're not facing each other this time. So again, I need to find that top angle to use the sine law. So then once I find this top angle, I can solve for the question mark. But before I do that, I need the x angle down here. Note this time that that angle x is an obtuse angle. So the obtuse angle is going to be bigger than 180 degrees. Just keep that in mind. So for angle x, we do it the same way. We say angle x is equal to sine 40 divided by 5. Again, we do that because 40 and 5 are right across from each other, and x and 7.5 are right across from each other. So that's going to be equal to sine x over 7.5. Again, sine 40 over 5 is 0.1286. That's equal to sine x over 7.5. What do I do? How do I get rid of the 7.5 on the bottom? I multiply by it. When I multiply by the 7.5, it cancels out, and I also have to multiply by 7.5 on the other side as well. When I multiply by the 7.5, I get 0.9645. That's equal to sine x. Again, remember when you're solving for an angle, we have to use the inverse of sine. So that if I have 0.9645, I can use the inverse of sine. Make sure that your calculator is in degree mode. I should get 74.68 degrees. We're going to round that off to 74.7 degrees. But remember that angle x is obtuse. The only way that we know it's obtuse is based on the diagram. This is why this is oblique trigonometry. It's not clear. It's a little bit unclear. Oblique is an angle that's bigger than 90 degrees. Sorry, obtuse, but it's unclear, ambiguous. Right? This is the ambiguous case. So angle x is obtuse, which means that I have to have 180 minus 74.7, which is going to be equal to 105.3 degrees. Okay? So now I know that this is obtuse. That's what I want. Now that I have the obtuse angle, I can find the top angle. And the top angle, I start off with 180 degrees. Now this is for an entire triangle. Is 180 degrees minus my 40, which is the bottom, and then minus the x angle, which I just found, which is 105.3, and that leaves me with 34.7 degrees. That's the top angle. So I can fill that one in. Top angle up here is 34.7 degrees. And that's going to help me find the question mark, which is right across from it. So again, I can use the cosine law or the sine law. It doesn't really matter. I like the sine law because it's a bit easier. There's only a few cases you have to use the cosine law in. So I use the sine law. And the sine law says that sine, I'm going to use sine 40 over 5 is equal to sine of 34.7 divided by my question mark. We've done this one a lot of times. It's 0.1286, which is equal to sine of 34.7 over question mark. Again, when I'm solving these things, I switch the places, or just remember that you have to divide, but it kind of helps you to know what to divide by what. So that means my question mark is equal to sine of 34.7 divided by 0.1286. Now, I didn't show this before, but when you're doing this on your calculator, a good method to use is, first of all, figure out what 34.7, the sign of that is. Let's try that one more time. So 34.7, figure out what the sign is. And then once I have that on my calculator, then I can divide by the 0.1286, and it gives me 4.4 roughly. So question mark should be equal to about 4.4 meters apart. Notice that we're much less distance apart this time than we were last time. And that's how to solve diagram 2.